So in this video, we particularly address the assortment planning example in the article. So this article talks about how the analytical analysis will help actually to optimize the assortment planning problem. Of course, the purpose or learning objective of this lecture is not to ask you to be able to optimize assortment planning, but it's a good way for you to see how the assortment can be actually improved from different perspectives. So the literature is from the Harvard Business Review. So the title, which product should you stock? And then they use a data or the example from auto retailer. The assortment is the car tires. So the main objective of this case or this literature is to summarize the essence of the attribute-based assortment planning. So this will be addressed in the article. I believe the article is well written and very easy to be understood. And then they also talk about the value of analytical approaches to optimize the assortment plans. First, let's see what is attribute-based assortment planning. So there is a clear statement. So there are actually plenty of softwares to actually help or support assortment planning. But at least at the publication time of the article, they realized that many of the softwares lack the ability to forecast the demand for new product or estimate how much demand would transfer to other products. So we call it a substitution or something. So the question is, when you actually edit the assortments, so if you drop one SKU, then which SKU should be added? Is that just that simple? You just drop one SKU and then you just lose the sales for this specific SKU. So the problem might be more complicated than that. So attribute-based assortment planning is rooted in the observation that most of the time customers do not buy products, but they buy bundles of the attributes. So you can actually look into this for many different products, for example, a television, a computer, or a furniture. And did you see, I want TV X, or you will actually think about what the screen size, what's the resolution, what's the price, what's the technology of this product, or what's the brand. So basically it's a attribute-based purchase. Now the question is, if you know how customer make purchases and then how this will be applied in the assortment planning. So based on the assortment planning in the historical records for a retailer, then we can see attribute-based assortment planning method uses the sales of existing products and then to estimate the demand for their various attributes and then use those estimates to forecast the demand for potential new products. We are going to talk about demand forecasting in next lecture, but that's actually a bit different from how we forecast the individual SKU's demands. Here we're talking about estimate also the correlated demand in one assortment. So approach is especially useful for retailers in the hard goods and grocery segments. So approach improves the currently approach, which uses the abundance of available market data to identify potential additions or SKUs a retailer doesn't carry that sell well at other retailers. So of course the current method, so you just see if the products sold well in other retailer, then you just take it into your assortment. But it seems still quite naive. So now let's see through this case, we try to answer the questions. So first, can we improve our assortment by replacing slow-selling products with new ones? So what is the likely demand for the potential new items? If customers don't find their ideal product, what is the likelihood that they will substitute another? How will sales change if we increase or decrease the number of products we carry? So does the localization, customizing assortments by store and store cluster make sense? If so, for which categories? If we decide to create clusters of the stores with distinct assortments, how many should we create, and what criteria should we use in creating them? So I think the article tried to answer these 4 questions, but it would be interesting for you just to focus on the first 2. So in the article, first let's start with how to identify the attributes particularly important for the customers. So now we are talking about an auto retailer. For example, T. Hansen, if you're in Denmark, and then they sell the brands and sell the tires. So now actually is the time to change the car tires, summer tires, winter tires. And you know, T. Hansen sells multiple, a big assortment of tires, and you can see they have the brands, they have a mile age warranty, and the size are the most important criteria or the attributes when customer makes the decision of purchase. So for example, the brands, we have the national brands or house brand or other things. The mile age guarantee actually is named as a high, medium, and low, and the size is actually named to A to O, in total 15 sizes. That's the problem, that's a case the article tried to investigate. Here you can see the historical data or the start of the analysis. So first collect the data from the previous sales regarding the, so on the top you have actually 6 combinations of the brand and mile age. So this actually addressed in the article why there are only 6 combinations are considered. And then there are also 15 the tire sizes. So it's a very complicated thing about the tire sizes. So it's 15 inches or 16 inches, and then 17 inches, 19 inches, and 21 inches. There are many different sizes. And the national brand, you have the high, medium, and the house brand 1, you have high, and the house brand 2, you have high and medium, and the house brand 3, you have a low, the mile age warranty. So that's the in this table you can see the actual sales for each specific SKUs. So these combinations each sell related to one SKU, and then on the bottom you have the total units sold for each brand and the mile age guarantee, and in the column you actually have the total sales for the total units sold for each size. And then furthermore, based on the total sales and the sales for each combination, and you can calculate share of the total sales regarding each brand and mile age guarantee. And then we have the current observations. So that's the expected sales proportions for each type of SKUs. Now the question is, we can estimate we are interested in total sales if we carry all these SKUs. So in this table, you actually can see you have the sales, a share of the total sales for each brand and mile age combination, and you also know the actually which SKU you carried. For example, for the size F items SKUs, this store carried 4 SKUs, so national high, and house high, and house 2 high, and house 2 medium, and then so that means if we sum up these 4 shares, 4 number for the carried SKUs, then you actually get the total. We sum up these 4 numbers, we actually get a total 87% of the sales. So we know in total we only this shop only sold 1,204 units. So the share is 87%. So if you divided this share, you actually can get the expected demand for this size F items. So that means actually there should be something missing. If you carry other items SKUs, probably can sell more. On the other hand, if we further look into this data or this number, we also find some problems. For example, we can see now if the expected total demand is 1,000, so 1,803 units, and then you expected sales share is 57.5%. So this value approximately equals to 796, which actually is greater than 767. So that means this estimation has some flaws. We needed to actually explore that. First, we can actually identify the discrepancy in this estimate, so we can refine the forecast. So the sales shares are influenced by the assortment offered. The house 2 high and medium actually were offered in almost every size. So that's why we have actually a very high total sales for these 2 combinations. And then we don't know if we carry others, will actually change this result. And correct the discrepancy, so we try to minimize the average difference. So this actually mean absolute deviation between the estimates and actual sales may help you actually to reduce the error caused by the current estimate. So in the Excel, I have shown how to actually refine the forecast. So the basic idea is we actually come up with a new decision variables called best fit demand shares. So which is different from the share of total sales from the current sales. So we assume these shares actually are decision variables, so we can actually change them. So you can use Excel solver to optimize these values by recalculate. So of course you need to calculate MAD. So this is shown in the Excel. So if you try to minimize the difference between the estimates and the real sales, and then you could actually estimate a most suitable demand shares for each carried SKUs. And then check the Excel calculation and see how we come to this result. So the basic idea is that now the demand shares actually are rather different from what we calculated previously based on the previous actual sales. So now you can see we have a new value. So if I change the color, now you can see this value for the house 3 low warranty SKU should actually have a very high sales shares, but this is actually not realized because they simply did not carry these SKUs. The manager's argument is they expect the customers will buy up. Then we can continue to see how this actually is realized. By refine the forecast, you actually can see still, if we look at the size F SKUs, now you can see the total expected demand actually up to 4,123. So this is actually a very interesting observation. We can also see for those carried SKUs in house 3 low, they actually also significantly more than have been sold for house 2 medium. So that means actually if you carry, probably have the potential to sell more if you carry house 3 low items. So after you found the best fit demand shares, then you actually can recalculate the share of demand captured, and then you can see for the size F items, you only captured 29.2% sales, and the expected total demand can actually up to 4,123. So we actually all know the forecast is never accurate, so we should be aware of the forecast errors. So in this example, we have two factors contribute to the forecast errors. First is there are random fluctuations in sales. So the previous sales is just an approximation of the real sales. Second, our assumption that demand for SKU equals demand for the size multiplied by the brand warranty share is imperfect. Because the share of brand warranty combination can differ by size. For example, demand was higher for low-end tires in sizes that fit older, less expensive cars than in other sizes. In the previous forecasting, we actually try to estimate the total sales for each size of the items based on the share of the brand and mileage guarantees. However, we missed one important feature of the demand forecasting. So here we did not actually consider the substitution because manager actually said they expect the low-end customers will buy up. So that must be some substitution existed. And then in order to consider the substitution effect, so we try to add extra parameters to the problem. So we define the substitution parameters. So the fraction of customers who trade up one quality level, who trade down one quality level, who shift from house 3 low to house 2 medium. So for example, here shift from house 3 low to house 2 medium. So that's actually the different substitution parameters we would like to consider. So the first type and the second type, we can call it generally trade up or trade down effect. So in the third one was particularly mentioned because the house 3 low demand of the market is really large. So we would like to separate this trade up effect from the others. So I actually did not put all these analytical results in the slides. So if you are interested, please continue to read the article and also check the Excel solutions. Now you can see what does it mean to consider the demand substitution effect into your demand forecasting. So based on the further analysis to consider the demand substitution effect, the demand shares for each, so the demand shares for sales shares, I'll call it, the best fit shares of each combination, and the trading up or trading down parameters actually optimized. Based on the updated information, we actually find that 35% of the house 3 low demand actually trade up to house 2 medium SKUs. However, this is not actually aligned with the expectation from the manager. The manager actually expect the more or many more the house 3 low demand trade up to house 2 medium. So the question now is, should this store change their assortments? So now the question is how to optimize the assortment. So need to decide whether to maximize revenue or profit. Need to decide price for potential SKUs. So decide on the final assortments. So that's one thing I actually did not mention in this video is the how well of on-hold or uncarried SKUs would be sold. So there are analytical results to show it's possible to estimate the actual sales if you carry all the other items in your stock. So now the question is they realized the current assortment is not the perfect. So they needed to actually improve this assortment. The article talk about a lot more actions, including to choose the right strategy to optimize the assortment. For example, need to first decide what to optimize, revenues or profits. So you have the course about the pricing. So if you maximize the revenue, basically you maximize the market share. And if you maximize profits, so not necessarily you sell the most. And then decide on pricing for potential SKUs. So this actually because when the customer makes decisions for trading up or trading down, they actually need to know the price actually plays a critical role. And then the idea here, the article mentioned, they could actually reduce the higher SKUs price or increase a little bit the lower SKUs price, and then the customer will may trading up more from the house 3 low items, and then decide on the final assortments. Again, this is not a simple task. There are a lot of things to discuss. So here, the article mainly talk about iterative process. So the idea is to replace the SKUs one by one and then re-evaluate the performance of the assortment until you do not have the opportunity to add more. So do check the literature and see what other effects or criteria should be considered when you optimize the assortments. In the article, the authors also mentioned in the end, they only actually implemented the optimal assortment partially in this retailer store or this shop or this chain. They actually improved the revenue, so increased the revenue by 5.8%, and then increase the gross margin about 4.2%. And of course, if you have other KPIs, you can also evaluate through the process. So I think the teaching method in this course is mainly to open the door for you. So it's really hard for me to teach all the analytical method within a 5 ECT course, but there are definitely a lot of chances for you to understand a lot of new issues and consider them when you make decisions in the future. It's not necessary you have to do all these dirty jobs. So we talked about the general merchandise planning process in this lecture. We talked about example about assortment planning, and we also we actually missed one more thing. Actually, is the on-store stock management. Is how to manage the products. So we call it on-shelf availability. So if we see on-shelf availability, so that's actually a question about how to optimize the allocation of the shelf space to your items. So if you're interested, you can also look into this article, and then there are some discussion questions you can try to find answers or comments. And then the fourth question, I'm thinking about, you could think about this as a inspiration for you to do your group work.